This is the 3.7 to 3.8 review. Number 3, calculators are not allowed. The goal is to find the nth derivative for the given function and value of n. So all three of these are going to involve trig functions who repeat every fourth derivative. They wrap back around to the original function. So if we look at part A, we'll do this one out in detail, and then we'll use what we discover in A to make the other two a little quicker. So we have our original function f of x equals sine of 3x. And I'm going to take a derivative until I start to see patterns. So first I see the derivative of sine is a cosine of 3x, and I have to apply the chain rule, which will give me a 3 at the back. My second derivative will be the derivative of cosine, which is a negative sine of the inside unchanged. I had a coefficient which stays the same, and chain rule will give me another 3. So now that 3 becomes squared. My third derivative, same process. I'll have a negative cosine of 3x, and I have to do the chain rule again, which means I'll get a 3 to the third at the back. My fourth derivative, here's where the pattern starts to come into play. When I take the derivative of negative cosine, I get sine yet again. So notice that on my fourth derivative, I wrapped back to the same original function that I had, but what's additional is this chain rule accumulation at the back. So that means my eighth derivative would be the same thing, sine of 3x, and I would accumulate 8 multiples of 3. I could do my 40th derivative, which again is a multiple of 4, and it will be the same function, sine of 3x, times that 3 to the 40th. So we're done. Now if we look at B, we'll notice that cosine goes through that same loop of 4, because we'll have cosine, negative cosine, sine, and then back to cosine. So we'll keep that same loop repeatedly. Now on this one we don't have to do the chain rule, so we are just going to move through that 2 every single time, and it'll stay there unchanged. So for part B, my fourth derivative will be the same thing. My eighth derivative will be the same thing. So if I go up to my 32nd derivative, I'm again going to have the same thing, and I'm interested in the 33rd derivative. So I take one more derivative, and I'll get a negative 2 sine of x. My last one, C, it's the 102nd derivative. Notice with C that I'm going to have that chain rule, so I'm going to be, instead of accumulating 3's at the back, I'll be accumulating 2's at the back, and I want the 102nd derivative. So that means the 100th derivative, which is a a multiple of 4, will loop back around to the original function, except I will have accumulated 100 of those factors of 2 at the back. So my 101st derivative is the cosine of 2x plus 1 times 2 to the 101th, and my 102nd derivative will be negative sine of 2x plus 1 times 2 to the 102nd. And we're done.